Okay, so the next 4 modules are all going to be about polynomials. So we're going to be learning adding, subtracting, multiplying, and dividing them. So this first assignment, we are going to add and subtract, and we're going to learn about them. So before we do the polynomials, let's talk about terms. So we have terms here are going to be separated by plus and minus signs. Ooh. Okay, so notice here you have a 5x squared. That is still multiplication in between the 5 and the x. So multiplication doesn't separate any terms, neither does division. So plus and minus will separate terms. And even if it's like something really long, so it could even be something like minus 3x squared y I root 2. There's no plus or minus signs in between any of these, which means this is all one term. So all this multiplication makes that one term as well. Okay, so but here the minus sign in between the x and then this whole thing, that separates those as terms. When we're looking at terms, they're going to be in this form here. So you're going to have a number. Does anybody know what that number is called? Coefficient. Good. So this is a coefficient. This is our x is our variable, which can also be our base. Variable. And then p is our power or our exponent. Now the power can be 0 power, first power, second power, etc. As a general rule, if you have a number by itself, so we can write that over here. Okay, so or a coefficient. That's going to be to the 0 power. Okay, and here's why. So think back to our last lesson where we did the 0 exponent power. Anything to the 0 power is 1. So for example, 8x to the 0, x to the 0 is 1. That's the same thing as saying 8 times 1, which is just 8. So an 8 by itself is technically x to the 0 power. Okay, so just the number by itself or a coefficient is to the 0 power. You'll have a couple of questions that are going to ask you if the term below is a polynomial or not. So pretty much everything is a polynomial. So a number is a polynomial, like this number 8 here. 8x squared, etc. Anything with a power is a polynomial. Here's your exceptions. So if you have a variable in the denominator, it is not a polynomial or a negative exponent, because a negative exponent is a variable in the denominator. You can't have any fraction exponents either. So you can't have an x to the 1/2, because x to the 1/2 is technically under a radical, and under a radical is not a polynomial either. Okay, and then a negative power is not a polynomial. So no variables in the denominator, no negative exponents, no fraction exponents, no variables under a radical. Those are your rules for not a polynomial. Everything else is fine. So if you have like 8xy cubed, that's a polynomial. Any power, as long as that power is not negative or a fraction. All right, now you have some special types of polynomials. So poly, the root word for polynomial, poly is Greek root many. Okay, so polynomial, technically many terms. Okay, but a polynomial can be anything. So all three of these here, these are all polynomials. These are just special names for them. So a polynomial with one term is a monomial, root word mono, meaning one. Okay, so ax squared and 4, both one term. Binomial, root word bi, that means two terms. So x plus y, 2 terms, 6y squared minus 2, 2 terms. They're separated by plus and minus signs. Trinomial, root word tri, 3 terms. Okay, these are examples of 3 terms. These are all polynomials. They're just special types. So then if I have a 4 term, I just say it's polynomial. So they're all polynomials. These ones just have special names. You're also going to be asked to find the polynomial's degree. So to do that, and you're only going to do this when you're finding the degree, because technically, mathematically, not something you would do to simplify. But if you're finding the degree, you can do this. So you'll take the variables and add the exponents. You're not going to add the exponents with any of the coefficients. Okay, so you can write just a little star here, not coefficients. Because remember, coefficients have an exponent of 0. So you don't need to add a 0. And then whichever one has the biggest exponent, that's the degree of the whole polynomial. So for example, okay, in example A, I'm going to take each term and I'm going to add the exponents. So this is x squared y. This x has a 2. This y has a 1. So 2 plus 1 is 3. So the term of this, the degree of this term is 3. Okay, so we're finding the degrees of each term. Then here you have 8xy squared. So we ignore the coefficient. We're just adding the exponents on the variable. So this x is to the first. So 1 plus 2 gives us 3. So this has a degree of 3. 5x, we're just looking at the x. That has a 1. So this is a first degree. And y to the 6 has a 6. So this is the 6th degree. So then we say the degree of the polynomial is the biggest one, which is 6. And then this is 4 terms, so we just say this is a polynomial. Okay, now B is how many terms? It's 1 term. So this is a monomial. Now, when I'm looking at this, remember, you're not looking at the degree of the coefficient. Now, this is 4 to the 3rd, but that's also just 64 if I simplify it. So when I want the degree, I'm just looking at the variable. So I look at x to the 1st, y to the 5th, and I add those together, which gives me a degree of 6. And then C is what type of polynomial? Trinomial. It's 3 terms. Then we have the degree on the x is going to be 2. Then the degree on 8x, that's just x to the 1st, so that's 1. What's the degree on 16? 0, because it's just a constant, which is 0. So the degree of this whole trinomial, that's 2. Yeah, the biggest one. Okay, so you'll be asked questions just about the polynomial, and then we're going to do some simplifying. Okay, so we've already done this a little bit when we were solving equations, but just to go over it some more. So when you are adding polynomials, you're combining the like terms. Like terms have the same exact ending. So you're looking at the end, whatever's after the numbers or the coefficients, they have to be exactly the same. So same degree, same letters, everything. So here, what are our like terms? Yeah, so we got 5x squared y and a 2x squared y. Why is the 10x squared z not a like term? Because it has the z. So they all have x squared, but they have to also have everything. So they don't. This doesn't have a y. These don't have z's, so we can't add them. So here I just do the coefficients in front. 5 plus 2 gives me 7, and then I just copy the ending. So I don't add anything with the variables. I just copy the ending. I add the numbers in the front. Then I bring down the 10x squared z, and that's all I can do. So a lot of the times now when I'm doing a problem, my answer isn't just going to be one concise answer like x equals 2. It's going to be longer things because we go as far as we can. So just some examples of like terms and not like terms. Things you can add and can subtract. So we have these rules for adding and subtracting. They have to be like terms. So you can always add any numbers, right? So 2 plus 10, we can do that. But we cannot add a letter and a number. So I can't do x plus 2 and get 2x. I can multiply them, okay, but I cannot add them. So it would stay x plus 2. So I can add 2x plus 10x to get 12x. Here, this would have been 12. Okay, but I can't do, for example, a 2x plus 10, because the 10 would also need to have an x. They also have to have the same degree. So if I have a 2x squared and a 10x squared, that's fine. That gives me a 12x squared. But I could not add a 2x squared and an x. Okay, because this x has a degree of 2, this x has a degree of 1. So they would have to be the same. And the letters have to be the same as well. So if I have a 2xy and a 10xy, that's fine. That gives me a 12xy. But if the letters are different, I cannot do that. And then things like the radicals need to be the same too. So if I am going 2 root 2x plus 10 root 2x, as long as the roots are the same, that's fine. That gives me a 12 root 2x. Okay, so notice every time I'm just adding the numbers in front. So even here, I'm treating that 2x like it's a variable, just copying it over. And then you want to be careful here. So if I did like 2 root 2x plus 10 root 2, I can't do that because this is missing the x. So the ending, anything after the initial coefficients has to be exactly the same. So you would not be able to do that either. So those are just some examples of your like terms and not like terms. So then let's do some actual operations with these. So for adding is pretty easy. It's just 2 steps. Step 1, you're going to just drop the parentheses. And then step 2, you're going to combine the like terms. Okay, so for my example, I have a 7y squared plus y minus 3 plus 7y squared minus y minus 7. So what I want to do here is combine the like terms. So when I'm doing this, you can use highlighters if you want, or you can, sometimes what I like to do is use shapes when it's longer. So I'll take my 7y squared and put it in a square, and then anything else that's got a y squared, I put in a square as well. So I'll put this. And I'm going to grab the sign in front so I know if I need to add or subtract. So then here I have 7y squared plus 7y squared. So 7 plus 7 is 14. And I copy the y squared. And then my y's, let's say I'll circle those. So there I have a plus y minus y, which is just 1. But what happens there? Yeah, they cancel out because 1 minus 1 is 0. And then I'm just left with negative 3 minus 7, which is negative 10. And then I'm done there because I cannot do 14y squared minus 10 because they're not like terms. Okay, then subtraction, slightly different because I'm subtracting. So what I'm doing here is I'm taking this whole first term and I'm subtracting this whole second term, which means my first step is I need to distribute the minus sign to the second parentheses. Then I'm going to combine like terms. So I'll bring down my first parentheses. So I have a negative x cubed plus x squared plus 9x plus 12. Then this is minus this whole thing. So this is technically a negative 1 that I can distribute. So negative 1 times positive 3 gives me a negative 3x cubed. Negative 1 times negative 12 will give me a positive 12x squared. Negative 1 times positive 3 will give me a negative 3x. Negative 1 times negative 7 gives me a positive 7. Then I'll combine like terms. So I'll start with my negative x cubed. Put boxes around those. So there I have a negative 1 x cubed minus 3x cubed. So negative 1 minus 3 gives me a negative 4 x cubed. Then I have a plus x squared plus 12x squared. So that is a 1 plus 12 will give me a plus 13x squared. Then let's use a triangle here. So plus 9x minus 3x. So 9 minus 3 gives me a positive 6x. And then I'm left with a 12 plus 7, which is a positive 19. So there I get my answer, negative 4x cubed plus 13x squared plus 6x plus 19.